Good morning, good afternoon, whenever you're watching this, I guess. We're going to be going over 6.1, or starting 6.1. We're just going to be going through half of it until no solutions and different types of equations. First, just learning about systems of equations. A system of equation is just two or more linear equations that have the same variables, meaning they both have x and y, or whichever variables, but you have to have two variables. A solution of a system of linear equations is any ordered pair that makes all of the equations in a system true. So on a graph, it is the point where the lines intersect. So these two lines intersect at 2, 2, so the solution would be 2, 2. Now, I think one of the easiest ways to find the solution to a system is to graph it. But once you get better with working with solving equations, it's actually easier, and my favorite way would be like using algebraically figuring it out. But we're going to start by figuring it out how to do it graphing. So, I can't erase that, but I'm going to try. On your graph each equation. I don't know why it's not letting me. There we go. Okay, so the first thing you want to do when solving a system of equations by graphing would be to graph them. Okay, so step one. There we go. Graph. You may need to, or you might want to, rewrite the equations so they can be graphed easily. Because these these are written in what form?
Point slope. Point intercept.
Slope intercept form, meaning you can tell the slope and the y-intercept from them. So those are going to be easy to graph. To graph in slope-intercept form, we first graph the 4, or the y-intercept. So I'm going to go up to 4. 1, 2, 3, 4, right here. And I put a point. And then from that point, I use my slope of 2 over 1 to find my next point. So I can go up to 1, 2, and to the right 1. Or I could go down to 1, 2, to the left 1. Okay? Now, I like to make a bunch of points down 2 over 1 every time I make when I graph these, because those are at exact points, and I guarantee one of those points is going to be your solution to your system of equations. Okay, so graph, we did not need to rewrite these because they are both written in slope-intercept form. Do you understand where I took the 4 first, or the y-intercept, graphed it, used the slope to find the next point from that point, up 2 over 1, or down 2 to the left 1. Down 2 to the left 1, down 2 to the left 1. And I could even go to there. Okay, then my second equation is again written in y-intercept form. Slope-intercept form, sorry. I always say y-intercept, same thing. Okay, I start at the 2. So I go up to 2. And what I should have done actually was connected these with a line. Okay, going back. Where do I go next from the 2? What's my slope of this line? 1. Up 1, over 1. Up 1, over 1. Up 1, over 1. Am I going to get to a point going that way? No, so I'm going to want to go the opposite way, right? Down 1 to the left 1. Down 1 to the left 1. Okay? Down 1 to the left 1. Now, I overlapped my other line, and that is your solution. Come on. Right here. The solution of that system of equations is -2, 0. Now, if you wanted to check it algebraically, you could put it into both of your equations here. Oh, you want to, hold on, time out. For solving a system, the first one is to graph it. The second one says identify the, what do you think? Identify the point where the lines intersect and write the answer as an coordinate or ordered pair. Okay. Now, if I wanted to check my work algebraically, I could go and put my -2, 0 into both of these equations, and it should come out true. And I will actually do that. Oh, that is the wrong. I will do that for the next problem because I have too much work on this one. Okay, again, first step is to graph the equations. Both of them are written in our slope-intercept form. So I'm going to go to my first equation, and I'm going to put my point at 6. Because a positive 6, if this was a minus 6, it would go down to 6, right? But it's plus 6. Then I'm going to go use my slope and go up 1 to the right 2. Now, if you notice, my graph is written in, do you have a different one?
Our graph is really different. Our graph goes 1, 2, 3, 4, 5.
Okay, so instead of 2, write 4. Instead of 4, just change your graph. It's okay. So because it's so big, you'll want to write, yeah, so your graph on your notes or in your notes goes by 2. So change it to, instead of 2, put 4. Instead of 4, put 8. Okay, and then if you notice, these are going up by 2's, correct? So 2, 4. So right in between here would be 5, in between this one, and then this would be 6, correct? If I go up 1, it would go up to 7, and over 2 would be over to, or, oh yeah, it would be here, right? Because I'm going over 2. My point would be right here. Now, if I label my graph by 2's, I can still go up 1 whole step and over 2, and it's still correct. Does that make sense? Okay, so how much am I actually going up? From this one to this one, I'm actually going up 2, correct? And from here to here, I'm actually going over 4, correct? Is 2/4 equal to 1/2? Yes, so the ratio is the same, so it's the same thing. I can go up 1 over 2 on my graph, even though it's up, actually going up 2 and over 4, but the ratio is going to be the same, and that's okay. All right, so now I have go up 1 over 2, up 1 over 2, up 1 over 2, or down 1 over 2. Am I doing that right? Down 1 over 2. Okay. I want to connect them with a line. Then I'm going to go on to my second equation. My y-intercept is -2, so I'm going to go put a dot at -2. Oh, I want to change colors. And then my slope is 1, so up 1 over 1. Technically, again, I'm going up 2 over 2. Does that reduce down to 1? Yes. Okay, so up 1 over 1 until I intersect this other line, which I did right here. That is my solution. Again, when I'm graphing, I want to make sure to connect all of my, I have arrows at the end of each line because it's a line. Did you go off your line? Did you go off your F?
I'm just confused because mine don't intersect.
Because the graph's not correct, it's not really.
Yep. So yours don't intersect because you have to continue going up. So you'll have to add on to your graph. Sometimes that's how. You might even have to make your graph go by 4s.
That still doesn't intersect.
Yeah, it's still on it.
I just did that and it just.
Go by 4s?
Yeah, I did 4, 8, 12, just by acting.
Because your graph is not big enough, correct? Okay, so you'll have to make your graph bigger, or you will have to rewrite your graph so it goes by a bigger amount. I don't know, by 6s, that would not be fun. But what is this point here? You might have to make your graph bigger. Okay, so over to 16 and up to 14, and that would be my solution. Okay, so what I was talking about before, I want a different color. I'm going to take both my equations, y equals 1/2 x plus 6, and I want to put my ordered pair, and you don't have to do this for every single one. Well, I take that back. I don't know about that. Okay, and I want to put my ordered pair that I say is a solution into both of my equations. So 14 is my y, so 14 I'm going to be replacing with y. 1/2 of x, which is 16, and then plus 6. Order of operations says I have to do the multiplication first. So 8 plus 6, does that equal 14? Or does 14 equal 14? Yes. This ordered pair made this one true, correct? Yes. Okay, then I can go, I'm going to erase my work because I don't have a lot of room. I'm going to do the same thing for my other equation. Y equals x minus 2. So 16 equals 4. No, I did that wrong. Sorry. So my x is 16, my y is 14. Does 16 minus 2 equal 14? Yes. So it made this one also true. Okay? Now, this one, I believe, is in your work, and we're going to do a lot with writing systems of equations in lesson 4, but I kind of just want to quickly go over this one just because it's in our notes. Sorry, guys. Am I still recording? Yeah, I only have a minute. Uh-oh. Okay. So, one satellite radio service charges $10 per month. So here we have rate. So it's going to be here. And I'm going to end my video and then I'll go through this. $10 per month, $11 per month plus the 15. Write your equation. Done.
Wait, no.
Your assignment is on Canvas. Page 367, 10 through 18 all.